Hello everyone, welcome to our EOGRRC research group. My name is Randy and I am a PhD student at the University of Alberta. My research is basically about a pore-scale visualization using micromodels. This research is very useful to evaluate the weathability effects on phase change, phase distributions, and also oil recovery in porous media.
Initially, most of the reservoir rocks are most likely water-wet, particularly sandstone. At this state, most of the oil phase is typically surrounded by the water phase. This circumstance prevents the oil phase from being in contact with the rock surface in the reservoirs. Moreover, when steam is injected into the reservoirs, the encapsulating water phase will be transformed from liquid phase to steam phase. This phase change at saturated stream pressure and temperature leads to direct contact between the oil phase and the surface of the rocks in the reservoirs. Favorable improvement was achieved after adding the potential chemical additives to the steam injection as a tertiary recovery. This effort was able to gain over 80% of remaining oil and diminish the residual oil saturation to below 10%.
Hi everyone, my name is Jinjin. I'm a visiting PhD student at the University of Alberta. In my research, the heat shield cell will be used to visualize how to enhance the heavy oil recovery by adding chemical additives to the steam flooding. This is a happening experiment. After adding heating, the steam chambers become bright white, indicating that the mixed-scope oil displacement efficiency is almost 100%. That's because heating can mix with net hydrocarbon components of the heavy oil to form a miscible loam. And then the heavy oil is driven by oil phase miscible flooding with no oil film retention. And the heating can significantly reduce the viscosity of the heavy oil and expand the volume of the heavy oil by dissolving into the heavy oil.
My name is Ilyas Alkindi. I'm doing my PhD program at the University of Alberta in Petroleum engineering. My research is mostly related to phase change of hydrocarbon solvents in porous media. Most of my studies are done by using microfluidic analysis.
Pore size has a big effect on phase change temperature depending on medium waterability. It either can reduce or increase boiling temperatures. Understanding this phenomenon could be critical in predicting the phase transition of injected fluids in thermal or chemical injection projects. Our studies focus mainly on investigating the phase change behavior in porous media by using microfluidic chips with different designs such as capillary tube, homogeneous and heterogeneous micromodels. As an example, here we have vaporization of heptane solvent in a homogeneous micromodel. Another example here is condensation of propane in a heterogeneous micromodel.